Hey everyone, Mr. Kimsing here, and today we are looking at Pareto charts. It's something new, it's something fresh. It's actually been in the standard course for a while, but I guess Advanced is playing a bit of catch up for once. What's the Pareto chart? Why do we care about it, right? Well, the Pareto chart is interesting because it combines two graphs that we're used to seeing. It uses a bar chart, and then it kind of overlays it with this line graph. It's a special type of line graph, though. It's a cumulative kind of line graph, so it's a running total. What's it used for? Why do we care about it? It was actually, interestingly, its roots lie in economics and business. It was invented, or it's attributed to a guy, and we name it after him, Vilfredo Pareto, who's an Italian guy, who's an economist. And he noticed that in his town, I believe, that about, or in the city, about 20% of people owned about 80% of the land, or the wealth that was there. And then you can see how quickly it drops off after that, right? The next 20%, they only had 11%. And then look at the poorest 20%, they only had 1% of what was out there in terms of income and wealth, right? And this is actually a big problem. If you study economics, it's actually a big problem in countries all across the world, this idea of income inequality, that the rich people have a lot of the world's wealth, whereas the poorer people don't really have much of that. And it's a very large percentage of people. So it's an interesting thing to look at. People have kind of adapted this to different kind of situations. So there was a management consultant, so a guy who looks at like strategies of businesses and different things that they can try and do to improve how they run. His name was Joseph M. Juran. And he basically attributed this principle to Pareto, and he called it the 80-20 rule, right? And the 80-20 rule is saying that work less and achieve more. So often the teacher says to you, work less. The idea is, well, sometimes teachers they say work smarter, not harder, right? They're saying, okay, what can you do right now that is going to be most effective for improving your situation, right? So if it's an exam, for example, don't focus too much on the stuff you already know really well because you know that stuff, right? Or don't focus stuff that you know won't make up a large part of the exam. If it's only like one little small component, right? If you can focus 20% of your efforts, you can get kind of improvement on 80% of the things in a situation. And that's kind of relating these two ideas together, right? Looking at the richest 20% owning the 80% of income. Can you focus 20% of your efforts and get 80% of the improvement? That's the kind of idea behind it. How do we look at this in mathematics? Well, in mathematics, like I said, we want to think about what it involves, a bar chart and a line graph, right? But I hinted earlier that it's going to look at two scales. Like we need something on the left and the right, okay? So that's just something to keep in mind. The important thing is that we can't really combine these two together, okay? So we need to look at these axes separately. That's very important. It's probably one of the biggest mistakes that students make. So look at the axes separately, all right? I'll expand a bit more about that when we look at the example. Okay, so here's our first example. A bank wants to identify the most significant problems it experiences when they're looking at credit card applications, and they conducted a survey looking into this, and the results are shown here. Okay, so we've got this table here. How do I convert that into a Pareto chart? First things first, we've got the right-hand side scale over here already, so don't need to worry about that too much. But this left-hand scale, we do need to construct. It's a frequency, right? So it's going to go up to 70 because that's the highest one that's there. So, I mean, when we're looking at this, I guess what we want to think about is what kind of scale do we want? Probably, given what we have here, we can go up by tens. I think that would be appropriate. So we'll start at 0. Right, cool. And then the other thing is that we have to order them from highest to lowest. Okay, that's really important when we're constructing this. So order from highest to lowest. So the table has already kind of done it for you, which is quite nice, right? So we start with no signature, that's 70, and then we go to the incorrect address, that's 35 and 21 and so on and so forth. So we'll go ahead and do that now. So I should put a total here. The total was, yeah, let's draw up these graphs now, right? So 70 is the no signature. So I'm looking at going up to here for 70. Incorrect address is 35, so that's roughly halfway between there. 21 is quite low, so around here roughly. and then 7, 7. So that's all the way down there. Okay, let's draw these up, these column graphs now. So, do my best to draw up a rectangle. There's our Pareto chart. Alright, so far so good. I've got my Pareto chart here. I've constructed up the column graphs, and they all work out. But then you'll notice, right, that, well, in most of the ones that we construct, this kind of value, this 70, went to the 100%. They kind of matched up. Now, I guess if you can draw it out like that, that's kind of ideal. But remember, I emphasized up here that the axes are treated separately. So these axes don't generally interact. So obviously 70 doesn't correspond to, 70%. But even if 70 was up at the top over here, right, even if I managed to stretch it out evenly, the 70 doesn't correspond with 100% either, right? What is 100%? 140 is 100%, right? And so this is where you need to be careful about seeing how these graphs interact with each other. The other thing is that, for example, if you look at this, 70, that's not 70% of the total amount. Like if you looked at the column graph and tried to align it with that, that's not going to work out either, because if you look at this one, well, 70 out of 140, that's 50%, okay? So we just have to remember that these axes are treated separately. So I read the left one, that's for the column graph. Okay, so the left side is the column graph. I'll just do that over here. So the left is for the column graph. And the right one, the moment I'm going to draw, is for the line graph. Yeah. Okay. But how do I actually construct this line graph? Well, I've added in 2 extra columns here that I'm going to use. It's percentages and cumulative percentage. So remember, a cumulative percentage is just like a running total. So when I'm doing this, I want to think about, okay, what's the percentage of the no signature? Well, that's 70 out of 140. I know that's just 50%. 35 out of 140, you can calculate it as well. That would just be 25%. These ones over here, I don't know off by heart, so I'm going to have to calculate those. So 21 out of 140, that's going to be 15%. And then I guess these would be 5% each. So these should add up to 100% when you add them up, and thankfully they do. Okay, what's the cumulative percentage? Remember, that's a running total. So it means up until this point, how many percentages, or how much percentage do I have? So the first one, obviously, because that's the first one you've got, it's only going to be 50%. But then if you add on the incorrect address on top, so you're basically adding this number, you're going to get 75%. It's a running total. You're adding these along as you go. What's the next one? Well, that would be 15%. So you're adding that on. That's 80%. Sorry, that's 90%. And then we keep adding these along as we go. So that would be 95 and then 100. Okay. So the idea is that you can use these cumulative percentages to... sorry, I just got a bit of delay here for some reason. There we go. Sorry, just catching up. The idea is you can use these percentages here in order to actually look at constructing your line graph, right? So how are we going to do that? Well, the idea is, all right, I've got my cumulative percentage. I need to use that. So 50%, this is corresponding with the right-hand side now. I kind of ignore the column graph. So that's 50% there for the no signature. Then the incorrect address, when I add that on, that goes up to 75% now. So looking at the right-hand side, remember, 75% goes for here. When I'm looking at adding in this incorrect address factor as well, okay? Then adding on the can't read signature should bring me to 90%. So I'm just going to mark these points along as I go. And then the wrong form, that will bring me up to 95%. That's looking up here, right? 95%. And then 100% once I add in the other bit, okay? So this is how I'm going to construct my line graph now. Typically they put them at like the center as well, and then we just connect these up. There we go. And there's your line graph that we've constructed that represents that frequency kind of total there, yeah? That's the Pareto chart. How do we use these to focus on answering questions? What 2 areas should the manager concentrate on improving? Well, there's 2 likely areas, right? They're the ones that take up the largest percentages. And it was the first 2, S and A, which correspond to no signature and incorrect address. Yeah, so no signature and incorrect address. And what percentage, the next question, what percentage of a problem does this solve? Well, if you're looking at it, you've actually got that answer right here. The cumulative percentage helps you answer that. It's 75%. or you can read it from the graph as well. That's 75% over there, because when you get to the first two, that's where it ends up. That's the line graph I'm looking at there. So 75% for part C. Okay. How are they gonna other kind of questions that they might ask you? So here's the one that we looked at earlier. They looked at related to the reasons of students arriving late, and the Pooja chart shows that information here. And a common kind of question is like, rather than just getting to construct it, they'll get you to look at this and interpret some things, and they ask you what percentage of students gave the reason train or bus delay. Well, if you look at it, train or bus delay is over here. And so what do you think a common mistake is? A common mistake is that they'll look at this and say, yeah, percentages, I know percentages, you just look over there, 15, okay? Now, I think this was an HSC question or a practice one. It was a multiple choice question. And so 15% was actually one of the options, but it's not the right option, right? Because remember, this left side corresponds with the column graph. And so this right side corresponds with the line graph, yeah. So what we need to do is we need to actually say, all right, I don't know the table that shows me the individual percentages. I definitely can't use the right-hand side to do that. So what I will do is I'll look at, okay, what's the percentage for the train or bus delay? That's 92% over here, because each of these on the right-hand side go up by 2 this time. So just be careful you're looking at the right scale. So that goes up by 1 little of those blocks. And then remember, because it's a cumulative frequency, right? So it's like it's been added on to the previous one. That's the idea. Like it starts off at what's this, like 38%, and then it goes up to it's a bit hard to read. Let's have a look. Can't tell if that's actually in the middle there or not. I'm guessing that's about 68%, or might be 67%. Either one. But then this one's very clear, right? This one over here, that one here is definitely going to be, if you go 2% down from 90, that's 86%, right? And so the idea with like a cumulative frequency, a running total, is that you're adding this on each time. So to get the individual one, what I need to do is I don't look at that number. I think about what's the difference, right? How did I get from 86 to 92? Well, that's a difference of 6%. So that's what's been added on top, and that's what's the percentage for the train or bus delay. It's 6%. Yeah, I hope that's really clear, and it's really important that you recognize that the right-hand side is a line graph. It's a cumulative frequency. It's a running total. You're adding these percentages on each time. So these values that you see here, like they've already had the values added on top. So that's going to be how we can work out this question here. How do I get from 86 to 92? That's 6%, and that's the percentage for the reason of train or bus delay.